Hey students, in this video we are going to look at simplifying polynomial expressions, but first let's review a concept that we talked about in the first semester, which is combining like terms to simplify expressions. So I want you to turn to page 188 and we'll look at doing the warm-up here together, a few problems. We want to simplify each one of these expressions, and you should recall that to simplify something is just to reduce or rewrite in the lowest terms as possible. So number one should be fairly simple for you, fairly easy. We look at the expression is 5x minus 6 plus 3x, and we would like to take this expression and just rewrite it in simpler terms. And so we can combine our like terms, which are the 3x and the 5x. So I know that those two can be combined. They're both positive. So if I take my 5x and I add it to my 3x, that will give me 8x. And then the 6, there's no other term in this expression like 6, so I just bring it down. And this would be my answer, 8x minus 6. Those 8x and minus 6 are not like terms, so we leave it as that. Let's look at one maybe a little more complicated, because I'm going to have you try the rest, but I'm just going over this with you for review in case you've forgotten since first semester. So let's look at number 3 here. So in number 3, we would like to simplify this expression. It says 8s minus 4 plus 4s minus 6 minus 5s. And so in this expression, we have several terms that are like. I have the 8s, the 4s, and the minus 5s. Those are all alike. And we also have the minus 4 and the minus 6. So those are also alike. So if I want to combine all my like terms, I first need to combine the 8s, the 4s, and the minus 5. And in order to do that, we simply just look at the coefficients, the 4, the 8, and the minus 5. I know that the 8 is positive, the 4 is positive, so we would just be adding those together, and the 5 is negative, so we would be subtracting that. We could rewrite it if it makes it easier, so 8s plus 4s minus 5s. And if you just put the 8 plus 4 minus 5 in your calculator, you would get 7, and then we would keep the s, because 8 plus 4 is 12, and then when I subtract 5, I get 7. And then if I look at the other two numbers, the constant terms, I have negative 4, and I'm going to subtract 6. So if you put that in your calculator as well, let's say you're not quite sure what the value is, I have negative 4, and I'm going to take 6 away from that, so it's even more negative. It's going to be negative 10. And then I can just write these together. Well, 7s is positive, so I'm going to keep this as 7s, and then minus 10. And this will be my answer here. So this would be the simplified form, because I can't do anything else, because this 7s is not like this minus 10. And so I want you to try and do number 2, number 4, and number 5 and number 6. And I'll check those before you move on to the lesson today, which is simplifying polynomial expressions. Okay, here we go. So now let's turn to page 192, and we'll look at some background information that relates to a polynomial. And this kind of just gives you some terms to be familiar with as we talk about polynomials. A polynomial is a monomial or a sum of monomials. And a monomial is just a term. So if we think about what a term is, and we go back to our previous problem, we started with 3 terms in this expression, and when we simplified it, we ended up with 2 terms. So this 8x is a term, and this 6 is also a term. And they make up a bigger expression that has 2 terms. And so in number 3, we had 1, 2, 3, 4, 5 terms. But when we combined the like terms, we ended up with 2. So now we can start to look at these expressions and giving them a name. Anytime an expression only has two terms after you simplify it, then we call it a binomial. So bi for two. And then anytime an expression has three terms after we simplify it, then we call it a trinomial, because tri is for three, like a tricycle. We won't worry about the degree just yet, but this is the standard form of a polynomial expression, that when we write out the terms, it should be in order by degree. So in this expression down here, we have 2x cubed plus x squared minus 5x plus 12. And this one has the highest degree, or the highest exponent on the variable. So this would be in standard form. Just like this trinomial here is in standard form, the highest degree is 2, so that term is first, and then 5x plus 2. And this is also in standard form as well, because when the x does not have an exponent, well, we know that you could put a little 1 here, and so this has the highest exponent for the variable. But our focus today is to simplify an expression involving polynomials, and then we want to also classify it as either a binomial or a trinomial or simply a polynomial if it has more than three terms. So I want you to turn to page 193, and we'll see if we can simplify these expressions. They look a little different than the ones in the warm-up, but it's still the same concept of combining like terms. So in exercises 13 through 16, we would like to find the sum. And so in every single one of these problems, you are expected to find the sum of these polynomials. So in my 13 and 14, I can see that in the parentheses here, I have a binomial, and I want to add that to another binomial. So same as 14. And in 15 and 16, I have a trinomial, because there's three terms, and I want to add that to another trinomial, because that's three terms. Now, it doesn't always have to be three terms plus three terms. It could be three terms plus two terms, or it could be three terms plus one term. So this is just how the examples look from the book. Before we can simplify these expressions, we first need to figure out how can we get rid of these parentheses. Well, we should know that parentheses indicate that we could be multiplying by something, or in this case, we're just grouping terms together. So if I kind of remember that if we could put a 1 here, right? If I were to take this 1 and multiply it by negative 4x or 9, it doesn't really change the value. So this is simply just negative 4x plus 9. And here I have a positive 1 again. And if I multiply that by 6 and multiply that by 14, well, I have a positive 6x and a minus 14. So this is just like the problems in the warm-up, where now we just have to combine like terms. Which terms are alike? Well, I have negative 4x and I have positive 6x. So if I want to combine those, I'm only really looking at the negative 4 and the 6. So in your calculator, you could take negative 4 and you can plus 6, and that gives me 2x. And then the remaining terms, the 9 and the 14, so those are alike as well. And again, in your calculator, you can take 9 and you can subtract 14, and we should get negative 5. And so this answer here is going to be the simplified form of this, and we can name this as a binomial, because in my answer I only have two terms left. And so I'm going to have you try this one as well, number 14, to see if you can simplify that expression. So go ahead and try number 14. All right, so let's look at number 15. We can do the same thing. I can put a 1 here in front of the parenthesis. I can put a 1 here, and just like the one above it, I need to eliminate the parentheses first before we can actually combine the like terms. So by doing this, I know that this 1 multiplied by the x squared multiplied by the 3x multiplied by the 5, that's not really going to change the value of any of those numbers, right? They're going to stay the same. So 1 times x squared is just 1x squared. 1 times 3x is just plus 3x. 1 times 5 is plus 5. So that just helps me get rid of the parentheses. And I can do the same thing over here. So 1 times negative x squared, so minus x squared. 1 times 6x, it's going to be plus 6x. And then 1 times negative 4, it's going to be minus 4. And then just like the one above it, and just like the problems in the warm-up, I'm going to combine my like terms. So we have to go through and figure out what are the like terms here. So I have an x squared here, and I have an x squared here. So if we were to combine those, I have a 1x squared, and I'm going to subtract also another 1x squared. So those actually end up canceling out, right? That's like 0. Now we don't really need to write the 0 here, but I'm just going to put that there for like a placeholder. That goes away because this is a positive 1 and that's a negative 1. So now we have 3x, and I'm going to add 6x to that. So I have 3x, and I'm going to add 6x to that. And that will be a 9x. And then for my last terms, I have 5 and negative 4. And if I combine that, that's going to give me just positive 1. So here we added these two trinomials together, so this one, and we ended up with this binomial 9x plus 1 as our answer. So I want you to try number 16 as well. So for our last example, now we want to find the difference, and this will be similar but a little different than the previous one where we were finding the sum. On this one, we're still going to consider putting the 1 in front of the parentheses. However, in the second term, I'm going to have to distribute a negative 1. So in this first one, 1 times g, well, that's just 1g. 1 times negative 4, that's just negative 4. But in my second pair of parentheses, negative 1 times 3g is negative 3g. And negative 1 times negative 6 is positive 6. Because we have this negative and we have this negative. They make a positive when you multiply. So now when we go through and combine our like terms, I have my 1g and my minus 3g. So 1g subtract 3g is going to represent or equal negative 2g. Put that in your calculator. Just put the 1 and the minus 3, and that should give you negative 2. And then here I have 4 plus 6. Well, negative 4 plus 6, and that's going to give me positive 2. And this is my result, and this is a binomial because it has two terms. And so I'm going to have you try number 18. And then lastly, for another example, I'm going to do the same thing here. Put a 1, put a 1. If I were to distribute this, negative x squared, or distribute this, negative 5, and then distribute the negative 1, positive 3x squared, and then I can distribute the negative x, positive x, and distribute this, positive 8. And then we can go through and combine our like terms. So if I look at, I have a negative x squared and a positive 3x squared. So negative 1x squared and then plus 3x squared is going to be 2x squared. And then I have this x, which is all by itself, so plus x. And then lastly, I have my negative 5 and my positive 8. It's going to be plus 3. And so we end up with a trinomial because it has 3 terms. So I want you to finish that And then I'm gonna have you look at